kick it off.
Yep.
Okay, you're live. Feel free to kick it off.
Yeah, so I think we can start now. So good morning, good afternoon, good evening, everyone. My name is Syed Bari, and I'm a chairperson for Hyperledger Telecom Special Interest Group. And we see use cases of blockchain in telecom industry in this special interest group. We started this group in 2019, and we wrote 2 white papers. One on inter-carrier settlement and one is on decentralized identities. So I think last year we started this guest speaker series, and today we have Syed with us from BDATA, and the topic of today event is cutting edge world lightest blockchain IoT solution. Welcome, Syed, and you can start.
Thank you very much. Can you guys see my screen?
Yep.
Yes.
So that's great. So
Yes.
Okay, great. So my name is Syed Bari. I'm the founder of BDATA Solution. We are a startup company out of Toronto. We have been working on creating a BIoT protocol, which is a very lightweight technology. It can be deployed on any device. So it's a device architecture agnostic, as well as operating system agnostic. Today's presentation, I will share like what are the challenges of the cybersecurity domain, and as well as I will cover the demo of our technology and some other pieces and the use cases that we have done. As a team, so we are basically funded by Ontario Centre of Excellence, as well as some strategic investors. We are a team of around 12 people. In our team, my background is engineering and the crypto mining previous startup. I'm the member of Cybersecurity Standard Committee here in Toronto as well. My co-founder, Owen, his background is computer science and electrical engineering. He's previously worked with Siemens. I have the technical advisor, Thomas. His background is the Festo. He was a Festo Dietix CEO for North America and Canadian region. Today, in this call, I have Pratik Patel. He's our blockchain developer, so he will give the demo of the technology. So these are the earlier recognitions that we received. So we won the first place at Rogers 5G cybersecurity competition. So Rogers is a Canada-based telecom company. We also won the 5G demonstration use case for Anchor. Anchor is one of the Canadian entity who basically have the 5G private infrastructure where we deployed our technology. I will get into that use case as well at the end. We also won the secure remote operation competition that was organized by a Singapore government entity in Singapore, and basically judged by the Halliburton and Shell. So just to get into the presentation, so today I will cover the recap of the recent cyber incidents that's happening, and I will cover a demo as well, that how the people are hacking their specifically air gap system, where some of the systems are connected to the internet and the rest is not connected to the internet, and still they get hacked. So I will cover some of the video that that's basically open source available. I will cover what are the risks in the cybersecurity domain and what should be the ideal solution look like. And then I will get into the BIoT, like what is the BIoT and how we can deploy it, as well as cover the architecture, simplistic architecture, as well as the device enrollment and the endpoint management demo as well. So currently, at least 99% companies are using the VPN technology to secure their IoT infrastructures. That's mean that basically they used a centralized approach, virtual private network, which is basically doing the centralized certificate authentication for all the devices that get connected to the servers. And we see that as a vulnerability, because once your centralized certification authenticate get compromised, then your entire network get compromised, and it's basically easy for hackers to scale up the attack to the multiple devices. And another vulnerability or the shortcoming of the VPN is basically it doesn't come with the intrusion detection. That's mean it doesn't read the device log. It's a software-driven solution that gets deployed onto the devices. And since there is no intrusion detection, so basically companies that don't get any notification or alert if somebody is trying to hack their system. Another vulnerability that's in the VPN technology is basically it's a password-driven technology. So it's very difficult for the companies to manage that what type of the passwords their employees are keeping on their devices. And the last piece is basically the compliance. So it's very difficult to make sure that all the devices on the network basically in compliance with the cybersecurity standards and best practices. So there have been many attacks. Recent one is basically a US-based colonial pipeline where hackers got the access to their infrastructure, and they basically asked the ransom money to counter or basically to give the system back to the company. And unfortunately, the company paid that ransom, which basically encouraged the hackers. There were other attacks as well. One of the attack was on Florida city water treatment system, where a hacker basically intruded into one of their devices and tried to try to basically increase the chemical injection onto the wastewater treatment plant to the poison level. Other cyber attacks is basically one of the cyber attacks was on the nuclear weapons contractor in US, as well as one of the ransomware attack on the Advantech IoT infrastructure. So these attacks are growing and growing in a very fast speed. So it's a lot of news you will hear in the coming days or very recently that you might have heard about the attacks. So this is basically the demo, which is available on the YouTube as well. So it's basically talk about how you can hack air gap system. So how the air gap system works, basically you have the two type of the devices. One are devices that's connected to the internet, some of the devices that are not connected to the internet. And they basically think that they have locked the USB port, they have locked the internet, so probably that device is secure and it cannot be hacked. But the problem with the IoT is these devices are deployed remotely with the very, very low, the supervisions. And if those devices have the USB port, then they are vulnerable, unless you have a very comprehensive intrusion detection or embedded security on those devices. So in this demo, what I'm showing is basically the person who has a USB, that USB basically has some script in it, and that script does the HID spoofing. So it basically, since the device is not connected to the internet, but once he enter that USB, that USB is not read as a USB, that USB is basically read as a keyboard. And then basically it has the script. That script reverses the TCP shell settings, and then it allow him to connect to the attacker servers. So the purpose to demonstrate this is basically to tell the customer or to tell the audience is basically hacking has not been that difficult in these recent days. So if your devices are out there, then you really need multiple level of security on your devices. Just to lock your USB devices or keep the devices out of the internet would not help. So in terms of what is at risk, it's a lot at risk, obviously, because these devices are going to connect with the entire network. So a lot of your assets are basically at risk. It could be your IoT devices connected to the operating system, critical infrastructure, and entire critical infrastructure can become, can be at risk. A lot of time in cyber attacks, basically they convert the data into the binaries, and those binaries cannot be reverted until you become the part of their peers. So that's how basically they ask companies to pay the ransom money so that they can convert the binary back to the data. A lot of companies, they lose their patentable or valuable data as well, and enterprise level downtime is one of the risks as well that happened to a lot of companies because their entire network were down for several days, and not only one portion of the network, the global network. And then companies has to pay a lot of money for the ransom. So these are the major risks that I think companies care a lot about. And the next topic that I have is what to consider in a cybersecurity solution to avoid these kind of the risk. So cybersecurity is obviously a very big target, a very big topic. And the thing that I have listed here, at least 3 things that the companies need to connect or have in their technology. So basically, one is the real-time intrusion detection. That's mean that the solution should be able to read the device logs and something that's make sure the device authentication and the device activities are basically logged and can be monitored. And the next item is basically the file integrity management. That's mean all the files on those devices are being monitored and managed to ensure that if there is any attack or something happening on those devices, it's visible and it can be countered. The third part is the cryptographic certificate authentication. That's mean that a lot of companies, they use single certificate authentication for handshake purposes, and after the handshake, they think that it's secure. But their packets are still visible, and their packets can be used for the intrusion. So what we propose that it should be that every time the transaction happen, it should happen with the separate key of the public-private key cryptographic authentication. So what BIoT bring and what is this about and how this work? So BIoT is basically it's a distributed network of endorsing peers as well as peers. So basically, it's developed on the Hyperledger fabric. So instead of having a lot of endorsing peer, we have a lot of chains running on those devices. Every chain is doing the authentication of its own. That make the system very lightweight in terms of the size as well as the consumption of energy. So a lot of companies, they have the public endorsing peers, which basically increase over the time, will increase the data duplication as well as the energy consumption. So in terms of our technology, we have multi-chain architecture, which is basically every segment or every feature of the technology is a separate channel or chain code. So in terms of the distributed network, this entire network can be deployed on any company. It's a private network of that particular company having their own endorsing peer, as well as having their own devices authenticating through that entire network. It comes with the intrusion detection. So it reads the device log. It reads, it allow basically to manage all the ports of the devices and do the authentication and enrollment of those devices. So how it works is basically you need to have this complete system deployed on your network, which will allow you to register your organization. Once the organization is registered, then basically you need to enroll the device. So the device enrollment will be based on the device unique identity or the board ID. So once the device is enrolled, then all the sensors connected to that device will be able to stream the data. So once they stream the data, so entire data will be encrypted, and every data point that's been encrypted is creating a hash for it, and that hash is stored into the ledger to provide the immutability, and then the data is basically used for the analytics. So there is a one server that's doing the encryption, and then we have one server which is basically recording the data and providing the analytics for it. So so this is the value proposition. I would like Pratik to share his screen and give us a quick demo of the technology, and then I will go into the little bit more details.
Sure. Can I please get access to share my screen?
Yeah, can you try now?
Sure. Can you guys see my screen?
Yes.
Yes, Pratik.
Okay. So I will log in here on the platform. I'll go on the inventory section and register a new device based on the current asset ID that we have. So the device is now registered, and I will deploy it on the device by just copying this simple command, which is a curl command. So this script will deploy the application here. You can see here that we are working on a Opto 22 PLC, which has sensors attached to it. You can see that the temperature data is coming from here, and the voltage data which is being read from here. We also have a Node-RED application attached to it, where we can see that the sensors here, and I have attached a simple function to it, which attaches values like the tag number, data type, and the data values. For our application, we have two options to connect to it. One is a WebSocket client, and second is an HTTP request. So yes, so the applications are now deployed on the device, and I can run it by typing a simple command, which is BIOT data. And you can see that the device is sending the data in completely encrypted format, and we should be able to see it here that it's coming from the device, all the data. Also, data management section, we can see that the hashes of all that data is being generated from the Hyperledger blockchain. Coming back to our remote management application, I can run it by typing a simple command, which is BIOT remote. And
So,
as
yeah. So this remote management basically enable companies to manage their assets remotely, since this will be used for the IoT devices, so they can see that performance of their devices, battery life, and other details, as well as they will be able to manage the different ports of the device, so they can enable or disable the different ports of the devices.
Yeah. So we can see the data coming here from the device, which will give an analytics of the RAM and CPU that's used by the device.
Syed, there's a question in the chat. Carl's asking, are you collecting the data from the PLC or from the edge of the IoT device or module?
From the PLC.
Yeah, so it's directly connected. So the PLC is directly connected with the sensors, and it's providing the data from there. Yeah. I think if the data is coming, can you check on the port remote management?
Yes. So here, on the device, we can see that the port 9078 is currently open, and I'll perform a simple application which will close that port. So once I perform this application, sorry.
Okay, so there are a few more questions. I think there's a follow-up of the previous questions from Carl, asking how can that be really secure?
So, so making sure that how it can be secured, every time the data is coming from the device is basically having a separate, the keys for the authentication. So it's every time the key is it's not the same key that's being used for the other transaction. So every time it's keep changing, that provide the additional layer of the security on the top.
So we can see the data, the analytics data coming from the platform here, and I perform the operation here. I can perform it again, and you can see that the operation is being performed here, and we can see that.
And a question from Roshan, how the Hyperledger will be deployed?
Yeah, so Hyperledger is being used to create the multiple chains. So that's a purpose that we have been using the Hyperledger. So as Pratik demonstrated here, basically you can do the change of the port status. You can enable or disable the multiple ports. The device logs will be coming to the analytic platform as well, that how much CPU usage or the RAM usage is. And from the data management, you will get every data point that's coming is basically having a separate hash for it. Is there any question on this? So I can move to the presentation.
Yeah, there's one more question and a comment. A comment from Carl saying you need AI at the edge to determine which data should be refined.
So in this presentation, I'm not covering our digital twin part, which is related to the AI and the other piece. So because the very detailed sections, so I will cover that for probably for another presentation or something.
Yeah.
So, Pratik, can you give me the access?
There's one more questions from Maha, and the question is, what sort of TLS version being implemented here?
So I will let Pratik to answer. I think it's a 3.2 or something.
Sorry.
TLS version, which TLS version we have incorporated?
It's 1.3.
All right. So in terms of the value proposition of the technology is basically it's include the MQTT, VPN, IDS, intrusion detection system, and the device management system. Companies get all of these applications separately, and that costs them heavily as well, and required a lot more resources to manage entire cybersecurity infrastructure. And they still come short on the security side. So we provide the BIoT protocol, which can be designed for the particular company needs, and it provides the real-time data streaming as well as the device log monitoring, intrusion detection, and the device endpoint management as well. So in terms of what is the difference between the existing technology and our technology, the companies, I think over 90% companies, they are using MQTT technology for the data streaming. On the left-hand side, I'm showing how it looks like in MQTT when they stream the data, and how it looks like when somebody used the BIoT technology. So on the left-hand side, you can see the data is quite visible. It's not encrypted. However, on the right-hand side, you can see the data is completely encrypted and securely delivered to the analytic platform. So what is the BIoT Security Hub? Again, it's a complete analytic platform, which I did not show in this presentation. It provides you the complete security analytics, intrusion detection, log data analytics, file integrity management. That's mean you will see if there is any, anything change on the file, you will see the file log as well as where the location of the file which was modified. Vulnerability detection will allow you to basically see if there is somebody from from not on your network is being trying to access your network. So all of this incident reporting, regulatory compliances. Regulatory compliances means that we have incorporated cybersecurity standards key factors, and we basically provide you the analytics based on those key factors. We read your device log and tell you that whether your infrastructure or that particular device is meeting those cybersecurity standards. So far, we have incorporated NIST, HIPAA, and a few other major cybersecurity regulations. So for the demo, the device that we use, it's a Opto22 Grove Epic. The device that we use had the 2 GB RAM and around like 6 GB user space. But for the BIoT, the technology has been deployed on very, very small devices. So the technology use only 50 MB RAM and 100 MB SD space. It has been deployed on multiple different type of the processor and operating systems. So this is a very simplified architecture of the device for our digital twin. So what happened, BIoT get deployed onto the device. So it reads the device log, provide you the device enrollment, hash ledger, data encryption, and the device log decryption. And then all the data goes to the data lake or the compute where the data is stored. So those are also part of the BIoT network. And then the BIoT Security Hub, which provide you the separate analytics for the security piece. We have provided our AI and machine learning model for detection of operating some kind of the predictive maintenance or operation analytics that we have incorporated in those use cases. And we provide the APIs that can be consumed on third-party cloud like Oracle or SAP or different type of the ERP products. Or you can use our digital twin analytic platform. So where the BIoT is being used, it's a lightweight, low latency, low power consumption, low processing requirement. technology. It's being used for the cyber hub, for the real-time data streaming, as well as emission accounting. We have done a use case for the SIM card defense. We are working for some use cases for the credit cards, as well as the POS devices. So this is a use case that we have been working in the defense industry with some Canadian military manufacturers to deploy our technology on some critical equipments. These are the use cases that we have been working in the industry, where we deployed our technology and provide our digital twin analytic platforms to basically monitor real-time data streaming coming from their assets. For the semiconductors, those are the the industry who get the first blame of any cyber attacks. So we have been working with Advantech, Supermicro, up to 22 Arrow. So these are the devices that we can provide with our technology pre-deployed on it. So we have signed a partnership with Advantech to co-sell the solution globally. And in North America, we have been working with Supermicro, also the competitor in the IoT devices. So we have been providing their devices, their hardware, that includes the data centers, servers, IoT devices, pre-deployed with our technology. So this is a use case that we did on the 5G. So Encore, as I mentioned, Encore is basically one of the Toronto-based I think not Toronto-based, it's also in Montreal and I guess Vancouver as well. So they provide the 5G infrastructure for you to real-time fast internet, as well as low latency data streaming. So we connected some of our devices for a mining facility in Syed Bari, and we basically remotely monitor as well as operate some of the equipment to prove the idea of secure remote operation and remote monitoring of critical infrastructures.
Sorry to interrupt. There's a few questions in the chat. The first one's from Maha, and it's asking, does the amount of traffic to be shared affect the key generation and crypto algorithm efficiency running inside the BIoT?
No, so it's a basically containerized based solution that we have developed. So it's basically do the load management of its own. So it doesn't impact on if the data is coming a huge amount or less frequency. So it basically is create more and more containers and do the streaming as it goes.
And also Nima Afraz, he said he couldn't raise the hand. I don't know if you want to speak out.
Yeah. Hi. Thanks, Owen, and thanks, Ed, for the great presentation. It's not very often we get like a full stack. We see like a full stack deployment of the blockchain, something that's functioning at the moment. So, and because of this, and because that you have been kind of providing this service for the customers. I was just wondering if, because the way you described the IoT use cases especially, and also 5G, I could easily see the scale of these operations to get really easily out of hand, right? So we are talking about sensors that are collecting data, and first of all, the number of these sensors could easily increase, and then the amount of data they exchange and send back to the servers and so on could easily increase. And with some of our own works that we've been doing, I've always seen that sometimes these factors could exponentially degrade the performance of the system. And I mean, I didn't really see much about like the architecture of the, let's say, the fabric solution you're using, or which fabric solution you're using. I mean, I don't expect you to probably changes depending on the customer you have. But what is the kind of resources, first of all, that you provision for this? And definitely this is going to be dependent on the kind of the number of nodes and number of organizations and number of peers you have. I understand that, but just for us to have a clue about what's been the scalability requirements from your customers' side, especially the ones related to the IoT. And how did you actually handle that? And have you actually kind of come up with a mechanism to provision resources for it? Thanks.
So as I mentioned, this is basically Hyperledger fabric-based. That's the core of the technology that we are using. And in terms of the explaining the entire course of it, I can share probably the white paper that has more detail on it, that has the detailed architecture of the technology, as well as how we are managing the load, how we are using the Kubernetes and the different technologies incorporated in to manage the entire load of the data that's coming to the platform. So there are two things, right? So we are not duplicating the data. So it's not basically duplicating the data to create the huge amount of duplication. So we are creating the hash of every data, which is basically providing the immutability. And it's all
right. So something similar to IPFS, or so is data data kept in a distributed manner or centralized? I mean, I understand that you hash it and you put the hash on the blockchain, but the data itself.
Data is not duplicated, so it's a centralized. It's stored on the server where basically is being used for the analytics purposes. So it gets decrypted and then it's used for the analytic purposes. But the but the duplication is at to the certain level. So we have an algorithm that basically derive the need of the endorsing peer based on the devices that you have been connected with. So there's a certain number of devices. If you increase more than those devices, then it will auto create endorsing peer onto the network to do the more authentication from the other the endorsing peers. So it's basically auto scaling up model that we have. So it's not like one static model that we have, and then if it's goes more than that, then it basically start disturbing the performance of the network. So this entire network is highly scalable, and it's highly basically manageable through the open source technologies.
Right, thanks Ed for the information.
Yeah, so I will share, or if you can drop your emails, if anybody in the chat is interested in our white paper, please drop your email in the chats, and we will for sure share our white papers. Thank you. I think so in terms of the core differences, these are the core references: firewall-driven security onto the VPN technologies, password-driven security. In our technology is a cryptographic chain of the authentication, and remotely manageable firewall settings. I have only a few minutes left. So this is kind of like our business model. That's basically license-based business model, and it's very compatible with VPN pricing. So that's pretty much I have in today's presentation. So I would like everybody, if you're interested, please share your email addresses, and we will send over detail the white paper that will describe our technology, how we are managing it. So it has the multiple chains, and every chain is doing the different authentication and processes. So that will be completely described in our
Syed, just one more question. Any use case where BIOT can be used for FOTA?
No, I don't have that any so far. Yeah.
Yeah, anyone more questions? Okay, so we have one more question. And can it run on small embedded devices, MCUs?
Sorry, I could not understand the question.
Yeah, Syed,
Okay.
can you hear me?
Yes, I can hear you. Yeah.
So yeah, we have one more question. Can it run on small embedded devices, MCUs?
So it's basically depend on what is that device, how small is that device. Our requirement is 50 MB and 100 MB's hard disk storage availability and 50 MB availability for the peers deployment. So if that device has that much storage available, we can deploy it. We have deployed on a small Raspberry Pis and a lot of those small devices.
Okay.
Yes, yeah, it can run on the microcontrollers. Yeah.
Cool. I think if we don't have more questions, so thank you, Syed. Thank you so much for the introduction, and let us know that how if as a telecom sec, if we can do some help, or if you want to do something with us, like as a white paper or something, yeah, please. And if you can share your white paper, that would be really good.
And we are as you know, we are looking for more and more use case deployment as well. So if there is any partner, we have done the use case for the TELUS to deploy our technology on TELUS SIM cards. But if there is any other telecom company you want to partner, replicate the similar use case for their their infrastructure, it can have the different performance based on your infrastructure. So it's worth having a use case at least to see how we can ensure the security of your SIM cards.
Cool. Okay, if we don't have more questions, I think we can end.
Thanks to everyone who joined the call. And if you'd like to continue the conversation around this topic or other topics related to blockchain and telecom, feel free to join the telecom mailing list. I dropped the link in the chat.
Thank you.
So Vipin, do we want to use the rest of the time for discussion of regular items, or?
In the agenda, we have this call only today, so yeah. We can...
I prefer the audit, to be honest.
Okay, great. Well, if there's no other questions, so we can end and then pick up a regular agenda next time.
Yeah, thanks. Thanks,
right,
guys.
Thanks, everyone.
Thank you very much, everybody.
Thank you, Syed. Thank you,
Bye.
everyone. Thank you, Vipin. Stay safe.